Okay, let me share my screen. Okay. So now we are in the next part of our session. So our next speaker is Gnanapalaniselvi Perumal. So she is working as a cloud DevOps engineer in Capgemini. She has experience is mainly in related services, DevOps, IP networking, and communication system. She is certified in Azure, GCP, and Kubernetes, and Terraform also. She is the active member of CNCF Stockholm Meetup Group and regularly attend the virtual CNCF events. She is interested in exploring more cloud native spaces and constantly working on upskilling herself with the latest technologies. In her free time, she is participating yoga and doing some walks and then spending time with her family. So this is what our next speaker is going to taking about Cilium introduction part. So yes, Selvi, you can proceed further.
Yeah, sure. Mira, thank you. Are you able to see my screen?
Yeah, yes,
Yeah.
Selvi.
So, so myself, Selvi. I'm based in Stockholm, Sweden. First of all, thank you, CNCF Madurai, for giving this opportunity to me. In today's session, like I'm going to give some kind of give overview about Cilium. So basically, it's like kind of the Cilium. It's a container networking solution founded by Isovalent, but currently it was maintained by CNCF. It is recently graduated by, I think, in the year of 2023. So why we need it? It's like, for example, if you want to deploy some Kubernetes, so we need to include some kind of network plugins like CNAs. For example, you already aware of Calico, Flannel, or ViewNet. Similar to that, it's Cilium now to ensure seamless connectivity between the workloads. Nowadays, it is one of the preferred option among the Kubernetes distributors and with the different cloud providers offering. It basically uses the EPPF technology. It means like extended Berkeley packet filter methods that provides advanced networking and security and observability features. It's not only for Kubernetes environment. We could use this one for multi-cloud and external clouds also. Using this technology, Cilium can able to achieve better performance with less overhead and low latencies, making it like more efficient option for networking, security, and observability task. So this is the overall architecture of the Cilium. So Cilium, it's like kind of the tool. It will help you to manage and secure your cluster nodes and servers. It includes as an agent that runs on all the nodes in your environment that provides a range of networking, security, and observability features to the workloads that is run on the worker node. So the agent is designed to work with both containerized workload and also those running natively on the systems as well. It provides advanced network capabilities like load balancing service, network policies, and logging and observability, and for the bandwidth management, etc. So all it the technology that will runs on the kernel space. So it means like we could basically the eppf, it what it will gives us, it makes our kernel kind of programmable. So in that way we can kind of reduce the n number of network hops that will communicate from user space to that send traffic to outside external workloads or something like that. So this is the overall solution that Cilium offer to us. It will work on all the major public cloud providers like AWS, Google Cloud, Azure, and also they have certified plugins for Red Hat, OpenShift, and VMware also. We could run Cilium on bare metal service like on-prem servers also. The features that Cilium offer, like networking, observability, and service mesh, and runtime security. So when it comes to networking, like we will have the network policies and encryption, load balancing, and multi clusters. So for observability, like it will have some kind of components called Hubble that helps to collect metrics, tracing, and logs. Then we can expose those things into the Grafana or any other things, Fluentd, something. I will explain in the upcoming slides about these things. So for service mesh, like kind of Syngress, authentication and traffic management. And recently they are introduced the gateway API, and they have some kind of integration with Skiffy. So on right side, like we will see the runtime security. So using this tetragon, they are integrated with this tetragon for improving, network security layer along with the runtime security. So what are the use case like we can use for the Cilium? It's basically like the container networking solution that provides highly efficient and flexible and scalable. It means like you can do routing as well as you can use it for overlay networking, for cloud provider native support networking, and also it supports like IPv4, IPv6, and network address translations. So using cluster mesh, we can support multi-cluster routing across the between on-prem and the cloud. So when it comes to load balancing, it not only support layer 3 or layer 4 load balancing, it also supports the layer 7 as well. And and it replaces the kube proxy. The we In normal Kubernetes we always have the kube proxy, but if you are using that Cilium, it will replace the kube proxy services that provides like high efficient Kubernetes service, and also provides like north-south load balancing based on the MACLove. Recently, they are introduced like a sidecar-less service mesh solution for the Kubernetes clusters, which reduce the latency and improve the performance compared to the other service mesh like available today in the market. For example, Istio or Linkerd that operates with a sidecar proxy. In terms of security, it provides identity-based network policies and the Cilium network policies. It also supports API filtering methods like HTTP, gRPC, and Kafka, etc. It also provides DNS server policies like, and also it encrypt using IPsec and WireGuard, TLS termination and injection. These are the securities like the Cilium offer to us. When it comes to observability, we will have the components called Hubble that provide observability, kind of give some insights about our call flows, network flows, provides metrics. Then we can export to Prometheus or OpenTelemetry or Grafana for better visualization and analyzing. For that purpose, we can use that one. Cilium, it's basically nowadays like all major cloud providers, for example, AWS, in EKSCA, by default, the default CNA is Cilium. And in GKE also, if you enable data plane V2, there is one option when you configure your Kubernetes cluster. So if you enable that one, you can utilize this, Cilium features. And Azure also, there is some service like Azure CNI supported by Cilium or something. So all the major cloud providers, they have some kind of plugins to implement the Cilium features, but it also have compatible with other CNAs. For example, if you have some kind of existing CNI, you want to utilize the Cilium feature on top of it, you can use that one. For example, AWS CNIs that will used for IPAM routing or device plumbing. So you can configure the Cilium on top of it to add features like load balancing, encryption, network policies, and multi-cluster and visibility. These type of features. Um, so in next, we are going to see about the security. So basically in Cilium, it works like kind of identity based security models. So how this approach is different from other security solutions means in Kubernetes, the context is the important things like we need to take care of because we have a number of workloads that are scaled up and down depends upon our requirements. It means like the IP address associated with each deployment and service or epidemic. So it's very difficult to keep track of all them in Kubernetes environment, especially in cloud. The IP address that is dynamically associated with workload, which makes it challenging to maintain that context. So, in order to overcome those challenges, Cilium's introduced like identity-based security model that provides context to your service and application running in Kubernetes that scale based on the kind of the context metadata context that you set on your deployments. So basically like here we are identify using the labels, right? So that gives a kind of unique identity that will used in Cilium for kind of a grouping or and also kind of identify the resources with the which service like we can tag with other one. For that we are using the label. For example, in order to track traffic for metrics or secure traffic, if you want to connect front end to back end, we basically using that network policies. In that like we will define that label as the identity unit. So this is kind of more efficient compared to with other in traditional way. It also support like API over authorization kind of not only it will provide security. Sorry, it means like we can use the Cilium network policies on layer 7 with the HTTP record, with the particular methods, for example, get methods, post methods, or something. Not only it support the layer 3 and layer 4 networking security, it also provides the layer 7 as well. So this is the sample example of the Cilium network policies that will create the HTTP hour rule. Basically, here what it will explain, it's like kind of we are kind of restrict some kind of HTTP access. For example, in these rules, like we will give permission to allow only for get methods with for public resource only. Like that, we can restrict the things. It also supports like DNS Cilium network policies. It provides like kind of many benefits for users who is working in the cloud-based environment. Uh, because in highly dynamic environment, if you want to connect your any external workload by using any DNS name or a frequent fully qualified domain names, you need for example, if you want to avoid the to keep track of the large number of IP address, because that will constantly changing, it will be very difficult. So in that case, like we will use this DNS name or FQDNs. For example, when dealing with media content that is stored in S3 buckets, so the IP address underlying these buckets can changing frequently. So by using the Cilium network policy, we can secure them through their FQDNs, and you can always ensure that the policy remain effective even as the underlying IP range. And also it significantly it have benefits like kind of instead of using IP address, if you go with the FQDN, you can easily secure your network against any attacks that target the specific IP address. It is specifically beneficial in cloud environment where IP address like kind of shared among the multiple workloads. So overall, the support for Cilium, DNS Cilium network policies, it's like kind of valuable features for any users who is working on the cloud-based environment. It also provides a more efficient and secure way to manage the network policies and also protect your network against any type of attacks. Cilium, they recently introduced the features called that Cilium Mesh. Basically, like they already have offered the features of installing agent on any VM or Kubernetes, where we can connect directly with the Cilium Mesh. But suppose if you think like you have any data, anything's or run on the on-prem or with any cloud other services. So how we can use to connect with the Cilium means using the transit gateway solution. So that will connect safely between the on-prem network to cloud resources. uh, for example, like use of hybrid cloud where you need to connect particular network, like those run on VLANs or subnets. So but the data that should be run on any on-prem material, on-prem servers. So to that one, like that this transit gateway solution, it will be like kind of useful. It will be ac- so it involves like using this CLMS. It will create like kind of overlay or virtual net routing environment, so that gives like seamless connectivity between the various environment. The Cilium offer the another features like kind of the cluster mesh. It's like kind of it's a feature. It will basically extend that security and observability across the multiple cluster. So if you want to secure anything between the clusters, then we will go with this functionality, cluster mesh. With this one, like each clusters like become an identity pool of service and application that enabling the use of the service managed load balancing, network policies and observabilities and encryption that can across up to 512 clusters. It also allows us to create multiple or hybrid cloud environment, ensuring like kind of high availability application across the clouds. Additionally, it provides flexibility to temporarily increase the workloads in cloud loads whenever it's needed. So if you want to migrate across multiple across seamlessly, this one it will be useful. Regardless of the underlying platform, it will be provide seamless networking service for your applications. This clusterness. So one of the use case of the cluster mesh is high availability. Uh,
Selvi,
so yeah,
sorry to interrupt.
yeah,
Can you go to the previous slide, please?
yeah.
Okay, I have heard about this on-prem and cloud on the first line, and what is that edge which you have mentioned over there?
Edge means in the telco, for example, we will collect the metrics with the edge, right? In telco environment, telecom.
Okay, so that
Uh,
is you mean to say this edges is specific to the telecom domain?
most of the things like yeah, edge they will, as for my like knowledge, like they will use it in telco environment. I'm
Okay,
not sure like if there is any other use cases available for the edge.
okay. Okay, fine. Because why I was asking is like so far I have seen only this on-prem data center and the cloud data center, and this since this edge was new to me.
Yeah, edge it's recently like kind of they are mm, for example, yeah, if you want to collect any metrics like that is nearer to your device, basically that
Okay.
will be like edge computing, right?
Okay.
For IoT, these things.
Oh, okay.
Yeah,
Fine.
but
Okay.
I'm sure like they in telco environment they will use this edge for collecting metrics. Then they will be store those metrics in some kind of centralized clusters.
Okay. Okay. Okay.
Yeah,
Got it. I think as like a log management, what we are using in the 12 setup, it will be separated from the actual processes. Okay. Anyhow,
yeah,
thank
yeah,
you.
yeah. No problem. So one of the use case of the cluster mesh is high availability. Suppose if you have multiple clusters, then you want to deploy application that has front end and back end. If you want backend service to be highly available across clusters, then you can use the cluster mesh. by using like kind of these things. It will be like kind of annotating your annotation, right? In service, like we will have one parameters like annotation. You can configure that as one as a global service. So Cilium, it will advertise the endpoints and make the global service across the clusters. So this way, traffic will be load balanced across the cluster. So when a backend service fails in one cluster, so traffic will automatically be sent to the remaining cluster to ensure high availability. The other use case is kind of the shared service. In suppose if you have multiple tenant clusters, so each one have own isolated environment. If you want to make a centralized cluster available for some shared service, like for example metrics or DNS or storing any secrets or other service, you can use the Cilium cluster mesh by connecting the clusters of the tenant with a shared service cluster. You can expose the global service such as the vault service that can be routed from given clusters towards the central clusters. Cilium automatically direct traffic to the centralized service clusters. Sometimes it becomes necessary to the splitting service, particularly when dealing with any existing cluster, especially when smaller or stateless clusters are involved. As yeah, previously, as I told, like in telco, the small edge clusters that collect metrics, but it doesn't store them. In that case, like we will prefer to forward those metrics of the client to centralized or some stateful clusters where the metrics can be stored in a data store service. The same principles can be applied to the data source in a given stateless and the edge cluster to automatically forward to the some kind of centralized cluster. So the only requirement for all this example is there must be free connectivity between the clusters, which can be achieved through some kind of dedicated gateways, VPNs, or other solutions. And the another features like we will have that local service affinity. It is basically like if you want to run your traffic within the specific like to avoid some kind of cost or latency issue, we can achieve this by using the local service affinity features. This is kind of enabled by using in service manifest. By using this annotation, we can configure as the service affinity is local, and if you want to make the backend service as the global, I mean for example, in case of any fail in one cluster, you want to redirect to another cluster, you want to send traffic to another cluster, in that case you need to configure the global service equal to true. So in that way, in case of any failure only, the traffic will redirect to another cluster. Otherwise, most of the things it will be like kind of take care by the local endpoints only, not the remote one. The other one is like the remote service affinity. Uh, these techniques where it will be used mostly, it's if you want to upgrade any, I mean, if you want to change any thing on your applications or upgrade in a cluster, so in that but you don't want to disturb the users, I mean the users still they wants to, if you want to still make the application available to users, in that case like the remote service affinity it will be helpful. It's basically similar to the local service affinity. You just need to change the name local to remote. Other than that, it's same only. So this is particularly useful when you need to upgrade or manage the application in a given cluster. Yeah, as those things on for those features, it will be like most useful. So once the maintenance and upgrade it, everything is complete. So we can flip around to local affinity again. So in this is like kind of simple to use and operate. This is an example of this network policies. So here like kind of we are allow this Basically, the endpoint selector, this is the one like it is the destination. So here, what we are doing, it's like we are allowing the X-Wing pod with the specific port number 80 to contact to that Ripple base, the another pod. That's how we are creating this network policies. Um, this is similar way like we can kind of restrict the traffic between one pod to another pod. So Cilium offered the service mesh as one of the features. So it has like it's similar to the Istio, but it not support all the features like what Istio provides to us. Basically, like what it will offers us like kind of the traffic management capabilities, including that load balancing layer 3, layer 4, um, and also like observabilities. So one of the key advantage of using Cilium, it's like kind of it doesn't need any kind of new control plane. For example, in Istio, like we will be kind of using control plane and data plane, but here like we are not using creating any new control plane. We have only the data plane that will run like kind of sidecareless proxy using this eppf native. I will explain like kind of about the traffic management option and the observability in the upcoming slides. So the main objectives of this Cilium service mesh is to kind of reduce the operational complexity. So while avoiding the use of the additional tools for various use cases, for example, not using the sidecards that have reduced the resource usage when compared, and also like kind of providing better performance using this extended Berkeley packet filters technologies. It successfully eliminated issues related to sidecar startup and shutdown, and also the waiting time required for the sidecar to be ready when scaling out the environment. So it means like for example, if you see in the diagram, like if you have to run the sidecar with then you need to, for each pod you have one proxy. So in that case, like there are you need to have like more resources. But in Cilium service mesh, like we were using that sidecar less, so it is like kind of um, reduce the number of proxies that is required for making that pods running. So if you're looking to use Cilium service mesh without sidecars, there are layer 7 traffic management option available today. It includes ingress, gateway API, Kubernetes resource services, and envoy config. That envoy config via the custom resource definitions, but it is not mostly used today because it requires like kind of high level of proficiency with the envoy. Yes, Gateway API is like kind of currently developing fast. We expect that in future, like it will cover all the use cases that we want to accomplish. And Ingress, like used for path-based routing and TLS termination. Cilium always also manage like egress resource without need for any external ingress controller, by enabling through some kind of simple Helm values. Cilium comes with an ingress controller out of the box. It requires some kind of integration with load balancer, either using like kind of cloud providers or with built-in load balancing capabilities. For example, in GKE, the Cilium operators will communicate with the cloud provider to obtain the public IP for the load balancer. So the public IP is attached to the ingress resource to forward the traffic. And the next one is Gateway API. This is the recently introduced features. It allows for the highly flexible and customized model for the network infrastructure management. It offers multiple layers of control and different roles for users depending on their needs. For platform engineers, the gateway APIs, it makes it manage the gateway and enables Cilium as the gateway controller. It means they can create one or multiple gateways, depends on the requirements of their project. They can also choose to have a shared gateway for multiple resources or dedicated gateway for specific teams. As an application developer, we can use this model to deploy our application and service within the given namespace. We can expose and attach them to provision gateway through HTTP route to resource. So this process is highly configurable and allowing us to easily forward traffic to the specific service. And we can do some kind of, if you want to do some canary rollouts or blue green deployments, those things also, like, we can implement using this gateway API. Overall, it offers like a powerful and flexible way to manage the network infrastructure with multiple layer of control and different roles for the users. It is ideal. This approach is basically ideal for the project that required high degree of customization and flexibility, and allowing teams to easily adapt to changing requirements and optimize their network infrastructure. So this is the YAML manifest for the gateway and HTTP. So if you want to create any rules, so first we need to configure the gateway. So using that gateway, then we will create the HTTP routes for the service, like where we want to route the traffic. And this is the example for the TLS termination gateway API. The next one is kind of observability. So if you for example, if you have large number of nodes or servers, so tracking, I mean, if you want to track those one using the IP address, it's like kind of tedious. So in that case, we can introduce that hub that will be like kind of usable for observability layer. So it is designed to provide some comprehensive visibility into your Kubernetes clusters. It captures all the flows, policies, and DNS events and present them in an easy to use interface that enables you to monitor and troubleshoot your cluster in easy way. It also integrates with other monitoring tools like Prometheus, Grafana, or open source for advanced metric collection and visualization. So how does it work? It's basically, it has like comprehensive network visibility and security solution. It having three main components like UA, CLI, and Hubble metrics. So UA is, it's like kind of user-friendly web interface that offers interactive topology views. Kind of we can see the network policy informations in this Hubble UI, and also like flow details all in the real-time environment. This interface enables users to explore and visualize, like collect data and providing service dependency map that shows like kind of how services are communicated within and between the namespace. They have some kind of built-in network policy viewer also, so where user can filter results and to gain the better understanding of the, I mean, like kind of the network traffics. Now there is like the CLI, it's like kind of the detailed flow visibility tool. It having more oriented for platform engineer that needs to extensive filtering and troubleshooting. It allows you to output to JSON, mean, in order to investigate further, to use in a different tool if you want to need. And we will have the Hubble metrics that provides the wealth of metrics that basically consumed by Prometheus and Grafana. Consumed by Prometheus and visualized by the Grafana. So the metrics includes like packet traps, latencies, or policy enforcement. So that helps user to track the health and performance of their clusters. Users can also configure specific metrics using Hubbles, like layer 3, layer 4, and layer 7 metrics. which can be exposed to other tools or platform to create the dashboards or monitoring specific events. And also like we can create alert for certain, if certain conditions are met, we can be alerted. So Hubble alerts like send real-time notifications to users when specific events or any conditions are occurred, like excessive packet drops or policy violation. So these alerts basically integrate with the either with preferred monitoring and alerting systems like Slack or PagerDuty that allows user to stay informed and respond promptly to any issues. So overall, it provides like comprehensive solutions for the network visibility and security, and also provides users to gain insights into their network traffic in case if there is any potential issue, like they can respond quickly. So in summary, the Cilium is like kind of highly effective and feature rich networking and security solution, basically designed for a containerized environment, but we could use it for I mean multi-cloud environment and on-prem also. But it's most used for containerized workload in Kubernetes environment, using the it built using EPPF technology, because before like we will use the IP tables, that one, but nowadays like in containerized environment it will be like kind of we have more service applications are running, so it is very difficult to track if we have IP address solution. So for that one they are introduced this EPPF technology. So this gives like kind of enables us to deliver unparalleled performance, scalability, and flexibility. So with Cilium, like we will have comprehensive features like container networking, multi-cluster routing, and API hour filtering to and observability. So its advanced based feature ensure that like our Kubernetes deployment runs smoothly and securely, and it makes the perfect choice for the many organizations that are looking to take their Kubernetes infrastructure to their next level. If you want to do some kind of hands-on lab, like you can go and visit this cilium.io. They have provided some kind of free labs where we can explore like kind of with different use cases. And Isovalent, it's kind of this is the company behind Cilium. They still provide Cilium enterprise support, but Cilium is available for open source also. Mm, thank you all for the and CNCF for giving this opportunity to present. If you have any questions, yeah, please let.
Yeah, yes, sir. We have a question from Muhammad, I think. Can you tell a sample project ideally using Istio, Hubble, and Cilium, which you can
Mm,
come across some real world example? Yeah.
yeah. Basically, like Hubble, it's like kind of the monitoring solution, like observability purpose, like we will use. Istio, it's kind of service to port to mean service to service encryption. So it will be like kind of provide encryption within the cluster. Um, Cilium, it will act on top of Istio. I mean, for example, egress. If you want to send any traffic outside your clusters, you need Cilium to encrypt the traffic. Is it? I mean, do you understand, or you still have any doubt?
Yeah, see the question is, can you hear me? Hello.
Yeah, yeah,
Yeah, see the question is,
yeah.
what is the condition? See, what is the criteria? I go for CDO and with this observability for the networking and other things, right? Compared to I can just go with the Istio and then Kubernetes without any
Y-
of this, right?
Yes, yeah. That's why I'm telling. Istio, it's basically like kind of work within the cluster, right?
Yes.
So, what is the purpose of using Istio? Like you want to, I mean, like
Service
encrypt the
mesh.
traffic between the pods.
Okay.
But if you want to send any traffic from mean inside pod to any external mean external workloads or outside world, in that case, like you need to come out the traffic mean outside the cluster. There you can use the Cilium. It will act as the networking layer. Um,
Okay, so if I have, a project with one, for example, 1,000 microservices,
hmm,
you know, and then I have another project which is having 10 microservices.
okay.
So, do I need to, which case I will pick, this Cilium? Because, see, this is mainly for, you told EBF and the networking and other advantages, right?
Yes.
So is it the one which is having more microservices which I'll go for, or?
Basically, it's not depends upon the microservice. It basically depends upon like how you want to send the traffic to external workloads. So if you
Okay.
want to like communicate, for example, if you have some kind of database service in any of the cloud providers, but you are using the clusters, that pod wants to communicate with those things. In that case, you need this traffic, and also like it's your requirement. If you are okay with some kind of send traffic without encryption, you can use it without Cilium also.
Okay,
it
so you're
it
to,
also depends upon the requirements.
okay.
um what I'm telling, it's like kind of so far like we don't have any solutions that support like egress gateway. Mean like kind of if you want to traffic anything outside the clusters for encryption, I mean like encrypted traffic. In that case, Cilium will use. But if you don't have any requirement, you are fine with, I mean, I am okay with to communicate with the HTTP instead of HTTPS, then it's fine. You can totally use with the solutions like what you have currently.
Okay, so from, you see, now you're telling I have one project, I have some, number of microservices, doesn't matter.
Hmm.
So the externally, the workload, right? That's what you're
Hmm.
telling.
Yes.
If that has more workload, then I'll go for
Mm.
this.
No, no, not external workload. Mean like kind of the workloads that is run outside your cluster. That is external workloads.
Okay.
It's like kind of egress, outgoing traffic. If you want to encrypt, then in that case, like you can use the Cilium. Um, but
Okay.
nowadays, like kind of yeah, you can use like instead of Calico or Flannel, like we can go with Cilium also. It has like many n number of features, so it's our preference, like which one we are go with.
But this is like a little complex, na, for configuration and all.
Uh, no, it's not complex. What type of complex? I mean, like when you deploying the clusters, so you basically installed like along with the CNI only as a default CNI.
Okay.
But yeah, in case of if you want to use service mesh, like yeah, then in that case, like you have to configure those things separately. So each functionalities, I mean, like it will varies the things like the configuration things and everything.
Okay. And you've been using this for any projects, or how is it?
Uh, Basically, like we had a talk, like nowadays only it's graduated, so many enterprise like they are preferring um, to use this Cilium for their network solution.
Okay.
Yeah, it's not. Yeah, I'm not like using it in any real time project, but yeah, we had some kind of discussion.
Okay. Thank you. Thank you.
Yeah, no problem.
Yeah, thanks, Sylvie. Thanks for the great session. Guys, if you have any questions, feel free to share in the chat.
Thanks, Sri. Thanks, great session. Thank you all for the participants.
Thank you, Salvam. Thank you, Veera.
Yeah, thanks everyone. So we will meet in the next wonderful session. Okay,
So
thanks.
we are not taking a group photograph, Veera.
Yeah, yeah, sure, sure. I forgot that we will do it. We will do it. Yeah. Okay, guys, let's turn on the video. Yes, guys, I took some screenshots. If you want to uh, be in the part of the sharing, you if you want to share your video, I can do that.
Also, the session will be uploaded into YouTube, guys. So we will let you LinkedIn to know about the